I'm Sonia Menezes. I was NMR lab manager for 46 years in an oil company in Brazil. And my title there was a senior consultant for NMR. Being in industry, you have to have a very good background because you don't know in advance what you're going to deal with. So being in a company that deals from exploration until new products, you have to have a very wide and very good background on NMR, because probably you have to use all the techniques and methods available to solve your problems. I've dealt with problems since the exploration of oil until bioproducts, passing by drilling, production, refining, new materials, etc. So you have to have a very broad and good background to deal with all those problems in industry, and every day is a different day. In high field and NMR, we had approximately 4 equipments, and very flexible, and with lots of accessories, which is very good in industry because you have to be fast. You have a deadline for each project. You have a budget, so you have to be simpler as well, as simple as possible. So I deal with high field NMR, liquid and solid state, and also TD NMR, which is very, very good. You know, if you want to control pilot plant or control process very easily and quickly. Sometimes you have to do your research first in high field and then bring this to the low field NMR and introduce in the system and make it very easy to use and very quick to use in, for example, a process or a pilot plant. Of course, you have to validate this methodology. You have to have a control very, very good of that methodology you introduce in the pilot plant or to control a process. So it's very different from academia. Academia, normally you generate knowledge either in methodology, either in pull sequences, either in a very specific research that you're doing. In industry, you have to solve problems. You have to answer questions, because people in industry, they don't know anything about NMR. They have a problem and they collect people from different area and say, I have this question, I have to answer this question, or I have this product that I want to generate, or this process that I want to generate. And then you see where NMR can help to solve that problem. It's a different thing. So you are part of the problem. Sometimes you can alone solve that problem analytically, sometimes not, but you are part of the problem. So you have to have the background, you have to have the equipment and accessories, and you have to meet a budget and to meet a time. You have a deadline, and you have to be quick and to be creative and to be simple. I've seen NMR solving many problems. For example, we have used TD NMR for the porosity and permeability of rocks. We have used NMR high field for solution to control many refining processes like FCC, which is fluid catalytic cracking, or hydrotreatment, which is very important process in refining. You don't know how a simple combination of proton and carbon-13 NMR can produce of solutions for those people. Is amazing. So we have developed a method that could produce results in a feedstock and a product of any of fuels that you generate in a refinery, or even more heavy products. And also for TD NMR, it's a control for fuel aviation. It's a formal standard method for that. And also we have used an example, TD NMR, to develop a method to calculate the amount of water and oil and drilling cuts for offshore production in a platform, because drilling cuts, it's a main problem in a platform. You have to throw it away, normally in the sea, but the environmental protection agents have many rules to do that. So you have to be quick to calculate how much oil. And so we're able to use TD-NMR, which is portable, to introduce a methodology very quick. You can do every 30 minutes or less, or 2 minutes, or every 30 seconds if you want, to calculate how much oil you have in the drilling cuts. And so throw it away in the sea, guarantee that you're not having a fee from the environmental agency. Those are some examples to see how the importance of NMR is for the oil industry. For the future, I would say that the oil industry is facing now the transition energy. It's on the way. Everybody's doing that. You know that the oil industry is a known pollutant industry, and so everybody is very worried about it and is doing something. And the transition to green fuels and biofuels will be inevitable. And the future, as organic molecules, NMR always has a role in this process, new processes or new products. I am retired now, but they are working full-time, very hard for this transition, energetic transition. And process like CCUS, capture of CO2, everything is on the way in our company, for sure. Petrobras, they have a session just to develop new catalysts, and catalysts are mostly zeolites for the refining or petrochemicals. And NMR is absolutely essential for the structure of those catalysts. By silicon, aluminum, phosphorus, many nuclei that can be observed by NMR are essential to do the characterization of the catalyst they are producing in their research. Another thing that I want to mention is about the use of softwares and automation. For industry, this is very, very important because you have a dead time. So if you have integrated softwares and automation for a method, for interpretation of a structure, everything that can help you to shorten the time that you give an answer or a result, I am sure that in the future, artificial intelligence will go into this place to help a lot too. For the future of the oil industry, I expect to go to biorefineries, biofuels, green fuels, to minimize the carbon balance of this situation, because you enter your car, it's in fuel, then you generate CO2, and you want to balance that by using more green hydrogen, green fuels, instead of a biorefinery using biomass instead of normal mineral feedstocks. Other thing is more useful, integrated, intelligent softwares that can help you to, go faster in your results.